Uh, Good morning all. Today I am going to explain about cryptographic hash functions related to the CO4. Here the aim of the session is understand the basic concepts of hash functions and applications of hash functions, and also we see the objective of this session is to introduce the basic concepts of a hash function. It provides the necessary theoretical background and demonstrate the applications of a hash function. Coming to the learning outcomes, at the end of the session you should be able to define hash functions and also list out applications of a hash function. Now I am going to describe about the hash function. Here this module defines the hash and message authentication codes, where the entire integrity has to be implemented using this first method. So this is the first method where cryptographic hash function is implemented. Here there are different applications are used. In this regard, hash and message authentication codes are plays a major role to implement this integrity. So in this regard, security hash function of the key length is 512 and MAC algorithms are demonstrated. And also we discuss about the hash value and how to calculate the hash value using the two simple hash functions that has to be discussed. Coming to the session introduction, this introduction describes the concepts of hash function, messenger authentication codes and applications of hash function. And also the exact usage of hash function is it accepts the variable length message and produces the field length of a hash value. That means it defines the integrity, check the integrity constant of the message through this formula. H is equal to small h is equal to capital H of M, where capital M means variable length message, capital H means hash function and small h means a hash value. So coming to the depth of the cryptographic hash function, where how the input is given to the hash function and how the output comes from hash function. Here the input to the hash function is a variable length message of M along with some fixed padding information, that is called, this is dummy bits added to the variable length to make the data to be fixed, so that the hash function can calculate the input of the message and produce the corresponding hash value of fixed length. Okay, is it clear? Coming to the properties of hash function, where there are certain requirements and corresponding description. First one is variable input size. Here we can describe the input of the given message is described as a h. Okay, and then what is the output size? Fixed size. Here h produces the fixed length output. Okay, so coming to the efficiency, h of x is relatively easy to compute for any given x, so that you can make the certain hardware as well as the software requirements based on the given input message, because here the message length is variable in, it seems. So we have to be define any kind of messages as an input to the hash function to produce the relevant fixed output, so that this function performs like a efficiency, it seems. And also the fourth category requirement is pre-image resistant. Pre-image resistance means it is a one-way property. For any given hash value, the small h is computationally infeasible, so that how do you find the value of y? Here the h of value of y is described as a small h. So that once you describe the input of the variable length, pre-image distance is required. Okay, and also for larger messages we are using second pre-image resistant. Okay, and also we have to see the collision resistant to manipulate the given message that has been that is to be infeasible in nature. Okay, last one, pseudo randomness also be one of the way to define the hash function. Coming to the self-assessment questions, so I have to be in order to describe the lessons. First of all, we see the what are the sort of questions will come. Okay, what does the hash function main function entails the to generate the unique identifier for the data. Okay, because hash function major motto is summary of the any user input. Okay, so summary. So every user wants to transmit the message to destination. Destination has to check whether the information which is received, which is correctly came from the sender. So the generator or a source make sure the instruction or the data has to be unique in nature by producing the hash function. So another question is which characteristics need to a good hash function value. Here there are three requirements are given, so that this all of the above is the correct answer to the given question. Coming to the self ability questions, self assessment questions, there are two questions will be given. One is defining collision resistance as the ability to generate a hash output that is difficult to reverse engineer. Okay, and also the fourth question is fourth objective type question is which of the following claims regarding the hash function avalanche effect is true. Okay, this is to be designed by small change in the input should produce the moderate change in the output. Okay. Another assessment questions are the hash output length is denoted by the digest. Okay, and also which of the subsequent attack looks for the two inputs that result in the same hash output. Because of birthday attacks, there are some certain attacks, birthday attack, as the major problems happen while you look up into the attacks. So the seventh question tells about the in hash function the idea of birthday attack relates to the finding two different inputs that produce the same hash output. Okay, this is the correct answer. And eighth question is which of the following is not a standard hash function in cryptography? MD5, SHA-1, SHA-256. Last one is AES, advanced encryption. Here the AES is not a standard hash function in cryptography because AES is a symmetric hash function. And ninth question is when a hash function consistently produces the same hash result for a given input, it is said to be non-deterministic, collision resistant and pre-image resistant. So here the pre-image resistance is constantly produce the same hash result for a given input. Okay, so the 10th question is which of the following is an illustration of a hash function that is not cryptographic. So here CRC32 is a CRC32 is a kind of hash function, but it is not a cryptographic. Okay. The summary of the this first session is it should be emphasized that any hash function must undergo a continuous scrutiny and evaluation to identify any potential vulnerabilities. Okay. So in the future research depends on the newer hash functions that incorporate the advanced security features. Okay. So the objective is to meet the ever changing demands of the hash function which are available in the cryptography to ensure the robust data protection. So these are the terminal questions will become. Okay. First one is define hash function. Okay. Second one is list of properties of hash function. Third one is represent hash functions in equation form. Okay. Fourth one is illustrate the hash function with neat diagram, and fifth one is define one-way property of a hash function. So these are the textbooks are used to read out this cryptography hash function. The first textbook, William Sterling's Cryptographic and Network Security Principles and Practices, is the prescribed textbook for your cryptography hash function. Thank you.